Alright, so for 32, again, on this problem I changed the reference points, keeping in mind that the parent function is x squared, y equals x squared. So I just picked -2, and when you square it you get 4, right here. And then +2, when you square it you get 4. The reason for that is because of the denominator right here, just to make my numbers, my transform numbers, to avoid diffraction, okay? So why is it 1/2? It's 1/2 because this is b, and we take the reciprocal of b. And then +1 because of this, and then right here y +1 because of this. Okay, so let's go ahead and transform the points. So half of -2 is -1, +1 is 0. And then 4 + 1, 5. And then 1/2 of 0 + 1 is 1. 0 + 1 is 1. And then 1/2 of 2 is 1, + 1 is 2, and then 4 + 1 is 5. Okay, so there's your points. 0, 5, 1, 1, and 2, 5. Okay, so that's a skinny parabola. Like that. Alright, so number 33 is another quadratic, but this time it's in standard form. And so when that's the case, it's best to find the vertex, and I use -b over 2a to find the x-coordinate of the vertex. So here's so b is 2, so -b over 2 times a is 1, so 2 times 1. You simplify it, you get -1. So now you need the y-coordinate, right? So to find the y-coordinate, you just plug it in, so you're going to put -1 squared into the equation, plus 2. So this is 1 minus 2 plus 2, so -2 plus 2 is gone, and you're left with 1. So the vertex is -1, 1. Okay, so let's go ahead and plot that. Okay, another nice thing about having the equation in the quadratic in standard form is that you know the y-intercept just by looking at the constant. So this is your y-intercept. So you don't have to plug in any more numbers, you just plot the point 0, 2. And because this is a parabola and you know it's symmetric about the axis of symmetry, you know that at -2 it's also going to be up at 2. Okay? And so that's basically all you need to draw the curve right there. 34 is asking for the x-intercept or intercepts, and basically that's the zeros of the function, okay? So we're going to see if it factors to find the zeros. If it doesn't factor, we use quadratic formula. But the first thing we try is factoring. So 12, factors of 12 that add up to 8, 6 and 2. So that one factors x plus 6, x plus 2, and that works. So then the x-intercepts are -6, 0, and -2, 0. Alright, so for 35, they want it in vertex form. Right now it's in standard form. So we are going to find the vertex. So you could do it like we did on number 33, where we use the x-coordinate is -b over 2a. So that would be -8 over 2 times -1. So -8 over -2 is +4. And then you find the y-coordinate by just replacing the x with 4. 8 times 4 minus 8, so that gives you -16 plus 32 minus 8. So that's, what is it, 16 minus 8, so that's 8. So the vertex is 4, 8. So you write your function f of x. The a value is the same in standard or in vertex. So the a value is right here, -1. Okay, so you just write negative x minus h squared plus k. You could also solve this with completing the square if you'd like, but this is just as easy to use. So on 36, they want the equation in vertex form of the quadratic or the parabola. They gave you the vertex and they gave you one of the points on the parabola. So I went ahead and I labeled the vertex with HK and the point with XY, and that will help you know where each of the numbers goes in the equation that's on the second line. So for Y, we're going to write 6. We're solving for A. We don't know A yet. X is -8. H is -6. Don't forget we square it. And then K is -5. So I'm going to add 5 to both sides, because again my goal is to solve for A. So 11 equals A times, right here this is +6, so -8 plus 6 is -2, and we're going to square it, so that's 4. So 11 equals 4A, divide by 4, and there's your A. So the function is going to be f of x equals 11/4 x plus 6 squared minus 5. Alright, there was a typo on part A. They should all be t's, not x's on the right side. They should all be t's, okay? So they're asking you for the end behavior, the right hand and the left hand behavior of the polynomial. And so first thing you need to identify is the leading term. So in part A, this is the leading term right here, -5t cubed. Okay, so that you could see right here that the degree is odd and the sign is negative. The A is negative. So that indicates that you're going to have a up and up, down in behavior. So that means on the left it's going to go up and on the right it's going to go down. And then for B, the leading term is the first one, 2x squared. So the degree is even and the A is positive. So this is going to give you an up. So on the left side it goes up and on the right side it goes up. We're finding the zeros on number 38. So first thing I'm going to do is factor out an x, because I see that they all have an x in common. So you're left with this. And so we have a trinomial that has an even degree as the leading term, and then the degree of the middle term is half, and it's a trinomial with a constant at the end. So I'm going to see if it factors like a quadratic. So are there factors of 64 that add up to -16? And there are, -8 and -8, right? So x, difference of squares, or not difference of squares, sorry, -8 and x squared minus 8. Okay, so it's the same factor. It's going to give you the same zeros. So you set each factor equal to 0, so you would say x squared minus 8 is 0, x squared equals 8, you take the square root. Okay, so that would give you plus or minus 8 breaks down into 4 times 2, so the 4 comes out as 2, and then this 2 stays inside. And then for this one, don't forget, that one's also a 0. So for number 39, I've set it up in factored form. That's the polynomial with the given zeros, the ones they gave you. And so all we have to do now is distribute the negative. So x minus 1 minus radical 5, and then x minus 1 plus radical 5. And we're going to multiply this out. So I usually use a 3 by 3. And place the factors on the outside along the edge. So x minus 1 negative radical 5, x minus 1 positive radical 5. We're multiplying. So I have x squared negative x, x radical 5, negative x positive 1, negative radical 5, negative x radical 5, radical 5, and negative square root of 25. Okay, So let's see, we can cancel out this one and this one, that's 0. And this one and this one, that gives you 0. And then right here, the negative radical 25 is actually, cross that out, it's actually minus 5, right? So now we can combine like terms. So f of x equals x squared minus 2x, and then I have this one and this negative 5, so that's minus 4. And that's the answer. Alright, so we've got to find the zeros on this one, all the real zeros. So when it's a 4-term polynomial, I set it up, I try to see if it factors by grouping. So I set up a 2x2 grid, place all the terms in standard form, so in descending order, and then I check to see if it factors. So factor of this row right here, greatest common factor, is x squared. And then x times x squared gives you x cubed. And then what times x squared gives you this? That would be 5. And then x times negative 4 gives you negative 4x. And then you check, is 5 times negative 4 negative 20? The answer is yes. So your factors are x plus 5 and then x squared minus 4. Now this factors further, that's the difference of squares. So that would be x plus 2, x minus 2, so the zeros are negative 5 and plus or minus 2.